Good morning. My name is Franciszek RAKOWSKI, and I have a pleasure to represent Polish cybersecurity company ICS, which is the producer and manufacturer of our flag product, which is called SCADVANCE XP. SCADVANCE XP is a system for intrusion detection for industrial networks. It is composed out of three components. The first one is the sniffing probe, which can sniff the network traffic in the industrial settings. Then we have a main computational server, which is the computational engine for processing and computing all the data which are taken from the network. And then we have a quite advanced graphical user interface for visualization different kinds of threats and analytic results. The key functionalities of our system is first of all to visualize the network which is under the supervision of our system. Then we can proceed with asset management, so we can make an inventory of all the assets which are in the installation. And last but definitely not least, we have a quite wide branch of methods dedicated to detection of different kinds of exploits and cyber threats. We can detect anomalies, we can list all vulnerabilities in the system, we can monitor processes and its feature, and we can of course manage all the incidents that were noted by the SOC officers. Within the project SMUAP, we have developed some new functionalities and new features of the systems. So, as we all know, the industrial cybersecurity market is young and evolving, and we need to rapidly address growing challenges. The SMUAP project, so the Industrial Automation Equipment Monitoring System for Cybersecurity, was developed to tackle the key technological challenges in Industry 4.0. The SMUAP project originated from the Research and Development Initiative co-funded by the National Center for Research and Development in Poland. And this presentation and article which companion this presentation presents its key research results now implemented in business activities. Okay, so let's move to the core of the functionalities that we have in our system. So the analytical module, which is dedicated to threat and exploit detection. And we can categorize all the methods into three categories. First one is the rule-based detection system. So we are taking the rules from out of the system. Then we can use a signature-based methods when we use different signatures composed also from somewhere else, from third-party deliverers. And finally, we can use behavioral methods, which quite heavily use the AI and machine learning methods. So let's focus on the topic of this presentation and the article. Let's focus on the anomaly detection. So let me note that anomaly detection is conditioned by the definition of the norm. When we talk about the anomaly, we have to have always in mind that we are referring to some kind of the norm. So what is the normal traffic in the industrial network? It can be defined in different ways. Let's say it might be a normal frequency of packets. It can be normal content of packets. It can be also in the multidimensional space a normal relation of the set of the defined or specifically defined features of the packets. In time series that we derive from the packets, which, for example, can contain the length of the packet or as it was said, the frequency of the packets, we can refer to the level of the values, for example, to the average, or we can also refer to something more in depth, more stronger, which is the morphology of the signal, so the shape of the signal. Let's see on a simple example what we can understand by the anomaly. So in the top figure we have a single point anomaly. In the middle one we have continuous anomaly, which is caused by the elevation of the average value of the signal. And in the bottom figure we have a shift and morphology anomaly. So we have a shift of the average and we have change in the morphology of the signal. On the other hand, we have multi-feature anomalies, which are a little bit more complex to handle, because it requires to construct a multi-feature model which defines the allowed space for coexisting traffic features. So we can describe a given connection in an industrial network by the set of the features and build the models to see where this connection live during the normal time of functioning, and all the points which exceeds the normal functioning of these connections we can call anomalies. Okay, so thank you for listening to this part of the presentation, and I'm handing over to Peter, who tell you a little bit about processing of the signal and its requirements.
Thank you very much. First, I will introduce myself. My name is Piotr, and I represent the Poznań Supercomputing and Networking Center, which was responsible for hardware design in our project. And I think that first we should answer some questions. The first is about central input and output objects that stand for data to be processed by network probe, or to be exact, in observation point. Well, I speak here about data in motion or streams, and they has its own specific. The second question is about data source. Of course, in case of industrial network probe, the data source, we have multiple data sources. Actually, narrow band ones, and also more frequently typical network adapters, network interfaces. And the third, I think, most important question is the regular or scalar CPU sufficient enough to perform efficient data processing? And the answer is not so simple, not so obvious, because actually, all in all, sooner or later, we'll end up with the conclusion that some hardware acceleration or even different approach to data processing is just required. And we can move to another slide. Next slide. I will try to point some disadvantages of general purpose CPUs. First of all, the biggest disadvantage is actually that CPU work, regular CPU work on data space addressable area, most often random access memory. And first, the data has to be shipped into that memory. Of course, we have direct memory access, but we have also to remember that in case of any task that is crucial for software system, it costs. We have to talk about costs, about loss of computing power. But that's not the biggest problem. The biggest problem from my, not only mine, but from my point of view, is that actually even simple operations may lead to instruction overheads, and which in turn will lead to lack of real-time capabilities. And like I said before, real-time is a big word here, because data to be processed by network probe has to be processed real-time. Of course, there are also architectural limits of CPUs to guarantee the orthogonality of instructions. And we can move to next slide right here. Well, that was the reason why we designed our own unit that was placed within FPGA, I mean, field programmable gate array device. We have dubbed it stream processing unit or SPU. And its biggest advantage is that actually it works on streams directly. So there is no need to load data to perform arithmetical or logical operation. It can, in basic terms, it can derive the data of any type from the stream and compose them and synthesis to perform synthesis of output stream. It is capable of stream decomposition and analysis. What is most important, that actually it can perform a vectorized operation. So it is capable of performing data processing, multiple data processing at once. The protocol-specific operations actually is based on a special program that is composed over a dedicated instruction set. And we can move to another slide, because last one is connected with a simple example that actually shows us what are the differences between regular or scalar CPU approach and SPU. Well, first of all, let's consider three words, consecutive words, actually, that represent some stream, some packet. That's not important here. Important thing is that they are consecutive. And let's say that actually we want to derive some parts, some subsets, substreams of that parts, and in result we want to concatenate them. We can say that actually this process is relatively simple, but that actually is the basic process needed to perform network traffic classification. And in the case of regular CPU, well, in each word we have CPU has to perform load operation, has to perform a data line by using arithmetical shifts, it has to perform logical operations. At the final stage, it has to perform concatenation using logical operations also. And in case of stream processing units, well, actually, the data in gray at the beginning and the A part, then the second gray part in middle, and the B part can be loaded immediately in one machine cycle. And that's the biggest advantage. Of course, there is possibility of performing many other operations, but we can easily see that actually there is a big advantage comparing to the regular CPU, and that leads us to a possibility of decreasing the frequency of processing. I mean, the clocking frequency, and that was the mechanism that was used in our networking probe. So thank you very much. That's all.